guys. Okay, let me share my screen. Okay. So we ended last time looking at how the Z effective and the nuclear attraction that occurs with an electron, and we discussed shielding. The other thing that I want to look at with you guys is this concept of where electrons originate and then distribute to. And so there's places closer to the nucleus, which would be lower energy, that electrons can start at or penetrate the atom, and then they can settle distribution-wise further away. Like some of us noticed, we have 4s and then 3d, and then it goes back to 4p. And so like the reason why this occurs is for that probability closer to the nucleus so that it can enter there even though it settles further away later on in the distribution. Okay? And so even though the majority of the distribution for 2s is further away than 2p, 2s fills first because the electrons can be closer to the nucleus, and then they move further away. Okay? It's also why they leave the nucleus in that order as well. Okay? So here we can see that the filling order is going to be 3s, then 3p, and then 3d right there. So here's that first penetrating peak, then for 3p, and then for 3d. All right. So as we discuss this, like that's where the filling order comes into place. And then they may settle a little bit further in those orbitals. And this is kind of just talking through that concept. In class, we went over how we do the electron configuration using the periodic table. So we already did that together. And we discussed how to do these unabbreviated and abbreviated electron configurations. Right. One thing I do want to point out, though, is we know that atoms are trying to seek that lowest energy, and a half-filled sublevel is lower energy than a partially filled. A fully filled sublevel is lowest energy, though. And so I'm trying to find an example that I can show you here. So what if we have the electron configuration, and let me stop sharing my screen. Stop sharing. Okay, so now you can see the board behind me. All right, so what if I want to do the electron configuration for chromium? All right. And so chromium, as we would follow that through, I'd have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1, 3d4. Okay. But I want you to imagine this. So I'm going to draw the orbital diagram for 4s and our 3d. So here is 4s, and then 2, 3, 5. Here is 3d. And currently it's saying that we have 4s has 2 electrons and 3d has 4, right? Only at the D4 and then also at the D9 do we get this exception? Because right now I have a fully filled sub-level orbitals that are the same energy, and then I have a partially filled sub-level. But half filled is lower in energy, so more stable. So what occurs, the atom can achieve greater stability if one of these electrons moves from the 4s and goes to the 3d. The other term I've heard for this is the 5d exception, because it's going from 4s2, it changes to 4s1 and then 3d5, and that's the correct electron configuration. So if I were to write the abbreviated for chromium, it'd be argon 4s1 3d. Okay. Like I told you, the other places is seen is with the D9, so copper. So let's change this now. Instead of chromium, look at copper. Okay. Copper, as we would count it through, we would expect for it to be 4s2 3d9. But how that looks here, so 1, 2, and 4s, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so now I see a fully filled and a partially filled because this guy's not partnered. And so one of the electrons moves. So now we have a half filled, which is lower energy, and a fully filled, which is lower energy. And so this changes to 1 and then okay. So now going back, let's share screen, share. Okay. So we've talked about all of these. Reminder for ions, that if it's a positive ion, then we lost an electron, and that is accounted for in the electron configurations. And if it's an, did I say, well, I said ion, cations are positive, anions are negative. If we gain an electron, then it's a negative anion, and we see that in the electron configuration. So fluorine has an electron configuration ending in 2s2, 2p5. And if we gain an electron, it changes to 2p6, which is the same as neon. So that's a noble gas configuration. All right. And then those were those exceptions, the D4 and D9 exceptions that I was discussing before. Okay, we'll start next class with this one. This will be our starter. And so then you have the 1.5 problem set that I want you to complete, and then you just finished watching this video. Okay, I'm so proud of you guys, and I'm so proud of all the hard work you're putting into this. So thank you. It's deeply appreciated, and I will see you all in class.